recorded anyway, so we'll have the recording posted into the group as name, right? Thanks for joining us. Looks like we're a little low on the attendees today, despite having quite a few sign up on the LinkedIn post, but it should be a good presentation regardless. So first off, I just want to thank everyone for coming here and introduce Adam. I'll give him a brief bio here in a minute. Before we get started, I just want to mention that we're always looking for people to present in different topics that would benefit you as well as the GIS community. So if you guys have any ideas or suggestions, please go ahead and let us know. Secondly, if you're interested in presenting, no matter how basic or complex the topic is, we want to hear it, and we definitely want to get that information out there for the community. And lastly, if you have any feedback for areas of improvement for this special interest group, please let us know. So today I'll be giving a brief background to this group for any newcomers on the call. Then I will introduce today's presenter. After the speaker introduction, we're going to jump directly into the presentation, followed by a live Q&A session. And finally, I'm going to wrap this meeting up by talking briefly about next month's presentation. This special interest group, FME and Transportation, was created with the purpose of curating and sharing success stories as well as best practices in applying safe software's FME to the transportation sector. The creation of this SIG was coordinated with the assistance of Safe Software, and it's meant to be vendor neutral. The special interest group was created with the hopes of unifying local governments and state level Department of Transportations, as well as the private industry. And we hope that it will serve as a holistic framework in which knowledge can be openly shared via monthly presentations from the community members here. These presentations are also intended to demonstrate and elaborate on real world applications and success stories. Outside of these presentations, we hope this group will serve as a sort of central repository for questions and answers as they relate to the transportation sector using FME. Today, we have Adam Tyra from Indiana DOT. Adam is an Indiana native with multiple degrees from Purdue University and a focus on transportation. After working for several years with private design consultants and acquiring his PE license in Indiana, he went to work for INDOT in 2015. At INDOT, he's focused primarily on asset management and improving related workflows. Through his work, he's incorporated different tools into his skill set, including Esri GIS products and most recently FME. For this work, he was awarded the 2019 INDOT Commissioner's Excellence Award for Outstanding Creativity in Process or System. Adam considers himself fortunate to be happily married with two mostly lovely children. His favorite transformer is the Attribute Manager, and his least favorite food are clams, mussels, and oysters. And just so you're all aware, Adam is currently suffering from an inner ear infection, and he's having a little bit of difficulty hearing. So because of this, if you could please type all of your questions into the chat, and that way he can read them rather than trying to hear you, that would be best for everyone involved. And now I'm going to go ahead and mute myself and let Adam take over presenting and share his stuff. Thanks, Adam.
Thank you. All right, so let me share my screen. Yes. So let's go screen. Share. All right, so let's see here. So the use case that we were tasked with in this particular case, we've been using FME for several automated tasks recently. And one of them that we were using was getting the bridge information that we need associated with its associated information, such as like traffic data and things like that might be on a related route ID, but that is not natively sitting on that route ID. So just as an example, to go through a few things. So a quick glossary of some terms to go through. So the first one, NBI, is in general, it's referring to the National Bridge Inventory, which is the standardized classification system for bridges throughout the nation. In this case, NBI is referring to the unique ID number. For bridges, it is typically a 6-digit for INDOT ones, often starts with a 0. And then the PK is short for pavement key. It's the unique identifier for the pavement sections that we have. So I'll show you examples of a couple of those. SPMS is our system that we use to track contract development. So it's used during like the design phase of a project and stuff like that. So the reason I'm saying that is because we'll get back to that here shortly in terms of saying why we need the information and what we hope to gain by running FME in this particular case. Then there's bias, which is a tool that was made by Bentley, I believe it was, but basically it's used for tracking MBI information. Then there's roads and highways, which is used for, it's Esri's linear referencing system solution. In this case, it's what we use for INDOT for our LRS stuff. And then there's route ID. I'll show you an example of how we have our route IDs. So for example, in this particular case, a one is short for interstate, 2 is US route, and then 9 is a state route. Then there's some stuff related to the counties, and then over here you see this 65, so this is I-65, so that's a route number associated with it, and then some additional information that's associated with ramps. Then down here at the end, some information associated with if it's a increasing or decreasing route. So if you see those numbers pop up, main things you need to focus on are the beginning, somewhere here in the middle, and then somewhere here at the end. So I'll show you a couple examples when we dig in. And then finally, county log just refers to county log is basically how we refer to our linear referencing system. So all of these route IDs are sitting on county log. So if you see that show up in FME, that's what that's referring to. So, so like I said, in this particular use case, we have information that is sitting on the increasing side of a route. So for example, the pavement keys are all sitting on the increasing side of a route. So we might want to associate a bridge with a pavement key. But then also we have the a lot of our traffic information and other things like that that's used for project development. So that information, when they're working in SPMS to develop the project, they need to quickly be able to associate that with, they need to be able to quickly associate that information with the bridge. The issue that we have is that bridges don't always fall cleanly on the increasing side of a route. So interchanges, especially these spaghetti type ones, are good use cases for explaining the different things that we could come up against. So for example, this bridge right here happens to sit nicely on the increasing side of a route. But this one adjacent to it does not, so we need to somehow snap it over here. We also have cases where we have ramps, where the bridge is sitting on a route ID that is not on the main line increasing or decreasing side. And then we also have cases like this where it's sitting off of a route that the route ID doesn't start with a 1, 2, or 9, so that it's not an interstate US route or state route, it's a local route. And so we need to get those to our routes so that we can associate them with our information. And then finally, we have some use cases where bridges, so let's see here, for example, yeah, so this is, yeah, so so we have cases like this where a bridge might straddle 2 separate route IDs. And the reason for this is because this is I-74 coming in, but then on the other side, so you can see 1 for interstate and 74. And then on the other side of it, it's old US route 421. So in those cases, we have multiple valid records for a given bridge, and it's where it's correctly located. It's just that it doesn't do us a whole lot of good when we're trying to associate with a single set of data. So that's kind of what we're up against, just so you guys are aware. So, so yeah, so taking a look at the workbench. So what I did was I went through and I basically outlined the different use cases that we might, or the different scenarios that we might run up against. And basically how I would go about associating that information with the basically increasing side of a route, so that way we would be able to get it correctly. So there's the first case, which is basically we take the route that it's sitting on, or in some cases the predominant route. So for example, that last one, it was predominantly on I-74. So if we just want a one-to-one record, then we want to say, okay, which one of these is the predominant one? And that will have the main prefix. So we'll get a main route ID, a main from measure, and a main to measure. And then we have the increasing equivalent. So that's basically where if it's sitting on the decreasing side of a route, then it will shift it over to the increasing side of the route. But that doesn't give us the information that we need for things that are ramps or things that are on local roads. So we need to do one more step where we say the INDOT increasing equivalent or the DOT increasing equivalent. And basically that snaps it to those route IDs that have the information that are associated on them. So those would be 1, 2s, and 9s, and then those would be the increasing sides of those at that. So no more ramps, no more local roads. So that would take care of that. Yes, John.
Hey, we have a question from Russell Cohen in the chat, and he asked, if I'm understanding correctly, it's the case that your bridges are a separate feature class rather than a linear or point event on your LRS.
Right. So here, let me show this so real quick. So if I zoom out a little bit, so we do have, so we have two flavors of our bridge features. So we have point features for our bridges, and those are typically located on the increasing side of a route. So in this case, because the ramp, because there's not a 9 here, that indicates that it's on the increasing side of a route, but basically it's sitting on a ramp. And so that sort of sits where it is. But then what you'll see right here is that, let me turn off these PKs because it's a little muddled. There we go. So if I click here, you can see that basically both bridges, both the increasing and decreasing side, are sitting on top of one another at the same point for those. So in terms of the terminology that I laid out before, those are the points are basically sitting on this increasing equivalent side. So however, what we want is, especially for really long bridges, so let me zoom out a little bit here and go over to this one. So we have a bridge that's basically, we refer to it as the monster bridge, but it's downtown Indianapolis. And basically it straddles a whole bunch of streets and stuff like that. However, if you zoom out, it is just associated with this one point, if we were just to go off the points. So we want to get a better idea of the from and to measures that most accurately represent the bridge. So does that kind of answer the question related to
that? Russell, if you want to unmute yourself or type in the chat, feel free.
It does. Thank you.
Okay, good. So yeah, so we also make use of the bridge points in the FME to pull out, to extract their route IDs in some cases. So yeah, so I'll start to get into that. So just to clarify in my own mind how I would go about getting that information, I laid out sort of a game plan for these different use cases to get there. I copied the information from a Word document into here. So it kept a lot of the formatting, but you'll notice that it didn't do very well by the outlining, but it's good enough for that. So I'm going to skip over a fair amount of this, but to hopefully hit on like the linear referencing specific items. But if anybody wants me to go back and go into more detail for anything, just let me know. So to begin with, we start with our bridge lines, and then we also have some other information that we're grabbing from sources like bias, where we grab a lot of attribute information, because most of our information that we're storing for bridges in roads and highways is not a lot of attribute information, such as like structure name or like intersecting route, carried route, stuff like that. We don't store a lot of that directly in roads and highways. Instead, a lot of that stuff is authoritative elsewhere. And so in this particular data set, what we want is we want to basically end up with a finalized data set that's fairly simple and streamlined. So what we're doing is we're grabbing a whole lot of information from our data warehouse that's pulling information from bias, and we're going to join it with the information. And so it's going to give us a lot of like the carried features, intersected features, structure names, stuff like that, that doesn't reside natively in our GIS information. So then a lot of this stuff is just cleaning up, making sure that's formatted correctly. And then what we do is, so in cases where there's more than one line per bridge, then we want to get that down so that we know which, basically it will create the geometry for it. So what we do is we say, okay, what's the furthest point for the original lines, and then if there is more than one feature associated with it, basically take the max value and then the min value, and then grab those. I was using sorters to go through and grab those. There's some weird cases where, such as, let's see here, I think this bridge over here would be a good example of it, where basically if I was just sorting based on the X coordinate only, it would give me something like this point here for vertices, but really I want to go from here to here. And so I had to rework how I was extracting those that information, add a little bit more logic to it, but I got that squared away. So yeah, it can't be simple. So let's see here. So yeah, at the end of all this, basically once I run my statistics, sort it, stuff like that, then I use the line builder to rebuild everything so that we get it back into a single feature per bridge. And while that's running parallel to it, I'm basically going through with some logic and saying, okay, if there is more than one bridge feature associated with it, what should be the predominant route associated with it? So in all cases, we're going through and taking the measure length, stuff like that, and coming up with the predominant route ID that way. Then the next step is we're just going through and taking the geometry from the dissolved information and recombining it with the predominant route ID. And then what we get at the end there is basically we've got a whole bunch of bridges. So we've got the bridge MBI, which is the ID that we're using, the main route ID, which is that first, coming back here, it's that first objective, this main route ID. That's the first objective, and then same thing with the from and to measure that we're pulling out. Then we go ahead and get the sample date just to help us track when it last ran, and then several other attributes that we were pulling out of the data warehouse. So then coming back to it, so now we need to go through and we need to say, okay, what's the increasing equivalent side of that? So if we were to just take everything that was on the decreasing side of a route and move it over to the increasing side of the route, what would that increasing side of the route be? There's some weird cases where, like typically what I would like to do is, say there was a 9 here, I would like to just move it over to say, okay, we'll just replace this 9 with a 0 and say, okay, in this case, if it was 9-1, then it would be 0-1, and that ideally would be the increasing side of the route. However, we have some other cases where sometimes they'll come sequentially, And because of how they were set up in the road inventory, it doesn't necessarily work that way. So if say there was a 9 here and there was, so say it was like 9-1 on this side, but the increasing equivalent side was actually 0.5, then it wouldn't work in that case. So ran into some fun stuff with that. So there's some logic built in there to test for those to see, hey, what's actually closest to it. So some other stuff to clean that up and pull that information down. In a lot of cases, you can see here, coming back to the bridge points, in a lot of cases, since the bridge points are already on the increasing equivalent, pulling that data from there is how we get a lot of the legwork done for that. So let's see here. In some cases, though, the bridge points, they're, depending on how carefully the inventory was, we might get duplicates associated with the bridge points for a single bridge, especially if it straddles more than one route ID. But then we, so to get the beginning and end vertices. So this was all, so this first step back here was just to get the equivalent route ID. And then the next step is to actually find out where those from and to measures lie. So we were basically taking the beginning and end points, breaking those down into their individual vertices, and then snapping those back to it. So this snapping occurs over here. So I found the anchored snapper tool to be quite useful for this. The reason I like it is because you can snap to a specific route ID. When in the past I tried doing something similar to this using ArcMap Model Builder, it was something where I had to take the information and put it in a loop to assign the route IDs correctly. But in this case, I can take all of the data and just say, hey, only seek out the route ID that I'm specifying for it, and it saves me a ton of time for that. So that anchored snapper tool is quite useful for that. And then let's see here, going along. Yeah, so right here, so LRS, Rev, Geocoder, and John or Bo, Rev, I'm assuming Rev is short for reverse, right? I don't think we ever clarified that, but
that's correct, yes.
Sorry?
That's correct, yes.
Okay, good. Yeah. So in this case, so what we're doing is once we have our vertices, we know our beginning and end vertices, and we want to take those. Then what we do is we grab the this Rev geocoder and basically say, okay, the route ID that you're wanting to snap to, we need to get the measures for it. So we've got our from X and our from Y to X to Y for each of those, and the counter in this case, we're using that to just function as a unique ID that I can make use of later. So that way that I can pull that information out. So yeah, so because it's expecting that unique ID for it. So then once we're done with that, then we get our from and to measures in there, and everything should be pretty good to go. A little bit clean up down here, but then otherwise we pretty much at this point have a lot of our information associated with our main route IDs and measures, and then over here we've got our increasing equivalent from and to measures and route ID. So now we've completed step 2 of 3, and so then the last step is the trickiest in terms of saying, okay, if it is not just the increasing equivalent that you're after, but you actually want it to snap to a route ID that's a INDOT owned route and the increasing side of that, what's that last step that you need to take? So the first step was just basically to say, okay, which ones are already sitting on one of those routes? And so we go ahead and just take those and clean them up a little bit, pull, assign some attributes, but otherwise that's good to go. Tier 2 down here is find where they're sitting on an INDOT route, but it's a ramp or a collector distributor. And so pull those out and grab those. So the first one was basically we had to say, okay, which ramp do we, or which main line do we assign this to? So what gets tricky is in cases like this, where you have this ramp coming down from I-465 southbound and going to I-70 eastbound. In this case, what do we assign it to? So it's a little bit tricky if you want to say, okay, is it closer to one end or the other? And there's some logic that you could put into it. In this case, we decided to just keep it simple because there's a route that's associated with it already. And so in this case, it was I-70. In this case, I-70 is associated with all of the ramps at this location. And so we went ahead and said, all right, like in this case, we're not going to worry about trying to snap it to 465. We're just going to snap it to I-70, and that'll probably give us the information that we need, at least for the moment. There's room for, I think, for process improvement in the future, but at least for the moment, just to get as close as they were currently in their process when they were doing it more manually, I think this fits the bill for the time being. Yes, John.
There was a question in the chat. Do the bridge points represent bridge centers or bridge starting points or ending points?
Oh, so typically, I think they often will represent roughly midpoints. So it's not necessarily the beginning or end, but I think typically it's more so the midpoint.
Got it. Thanks.
Good. So let's see here. So taking these for the ramps. So we wanted to, yeah, basically just some cleanup in terms of saying, okay, is this, what type of ramp is this, and how do we get it to there? So is this old route or not? And just some details on that. But basically at the end, what you're left with there is that we're going through and classifying it with saying like, okay, I think this is the right route ID that we want to use for that third step. And then this is the type that it is, which will come into play later over here. And so then if it's carried on a non-INDOT route, but passes over a primary INDOT route, then what do we use for that? So fortunately for us, we have I don't want to call it an inventory, but basically features associated with bridge clearances. So essentially what it is, for example, if we were sitting on so for like this bridge here, so this bridge goes over this ramp, over the main line right here. So what we have features for are, so say here and here, there are bridge clearance points that are associated with this route ID and this route ID that look back up to this bridge here. And so what's really nice about that is that it allows us to associate an intersection of a bridge with the route that it's intersecting underneath. So that basically allows us to say, in a case like over here, where it's not sitting on our route, basically we can say, okay, which route is basically the highest in the hierarchy that we can associate it with. So in this case, it's I-70 that we can associate it with up here. There's also a ramp here, but we ultimately want to snap it to that. So there's some logic in there to basically say, okay, take these bridge clearances, bring them in, and then look to see like using the sorter, and then basically the sorter will help us get to the point where we're able to use the duplicate filter so that we just get the highest one in the inventory that we want to get out of it. So so those bridge clearances are a critical point for getting that next step. So then taking a look down here. So then finally, the last tier, this is kind of the grab bag for everything that's left over after, if it didn't pass tier 1, tier 2, or tier 3, or if it did make it through all those gates and didn't get sorted that way. So these are all the ones that basically it's kind of in the vicinity, and for whatever reason, it doesn't pass over one of our routes directly, but we want to still associate with it. So in some cases, we have some like adjacent roads that might be passing over like a stream or something like that, that for whatever reason, we still have responsibility over that bridge. So in this case, we're just saying, okay, snap it to the nearest one, and we'll call that good enough in this case. So in this case, the vertex extractor, we're using that again along with the anchored snapper to come up with the ones, and then we're overlaying that with that, and then coming up with our route ID again. So, and again, just like the other ones, so in this case, the source is proximity. The source for this one was bridge clearances. And then the source for this one was that INDOT ramp CD. And that helps me know sort of how to handle it further downstream. So then we're basically combining all of these together, including the vertex numbers and stuff like that. And then we just recombine a whole bunch of the information to say, okay, that feature, that vertex number was associated with these coordinates, but then also give it these route IDs. So, so then taking a step back, so before writing out and doing a little bit of cleanup at the end, the very final step is basically, once we know that we want to snap it to that DOT increasing equivalent, then we go ahead and use our snapper, anchored snapper for that. And then we'll go through and let's see here. That's your point. Yeah. So eventually, so a lot of this stuff is just sorting and cleanup. So let's see here. Yeah, so depending on what the source is, then we'll go through for that. This is, what are we doing here? Yeah, we're just renaming some stuff for cleanup. We're extracting the coordinates, stripping out geometry. Thank you, Bo, for that suggestion. And then here, we're testing to see, okay, the vertex number that's associated with it, is that the minimum vertex number? And then so we're splitting it out. Yes, John.
Bo asked if you would be willing to share how the LRSE bridge line feature class was created or generated, and also to show us the attributes kept on that feature class.
Sorry, say it one more time.
Bo asked if you would be willing to share with us the LRSE bridge line feature class, how it was created or generated, and then if you could also show the attributes you keep in that feature class.
Oh, sure. So here, let me pull that up over here. Actually, let me connect to this one. I think it'll run a bit faster this way. So I'll get that queued up. So, okay, so while that's running, while that's getting booted up, I'll just finish this last step here, but then, yeah, I'll come back to that here in a minute. So essentially what we want here is we want to know, okay, which one of these points is associated with the beginning and which one of these points is associated with the end. So the tester sort of breaks those out into those two. And then we clean up some stuff, and then we join them together so that we get a consistent one. And then again, we use the counter, and then we use the reverse geocoder to say, okay, given that we know the route ID that's associated with, what are the measures that that we should be seeing there? So what we get is the from and to measure that come out of there. And then this last one, so tested. Yes. So in a couple cases, the other thing that we were seeing was that if the bridge was essentially parallel or sorry, perpendicular to the other route, we were seeing cases where the from and to measure might essentially be sitting on top of one another. And so if it was basically sitting on top of each other, what we were doing was we were adding just a little bit of measure to it, just so that it would break it out and be so that way it wouldn't be seen as only different out to like 9 decimal places. So we were fudging that a little bit just so that it would give it a slight bit of length so that it would show up. And so then the final thing was we bring them all back together and then just do cleanup so that it fits into the data set cleanly. And then we export that back out to the bridge lines data. So let's see here. I think the other one here. It's going to take a while. Let's go here. All right, I will pull this up. It'll just take just a second. While I'm pulling that up, are there any other questions in the meantime?
Not yet.
So also while that's pulling up, as a bit of background, the other things that we're hoping to, so we use these dissolved bridges for a few different things, including any time that we need basically one set of geometry for a given MBI. And so in this case, like we have been working on our 20-year plans for road and bridge, and then we'll expand that out to other assets, hopefully in the not too distant future. But basically, we have the let's see, bridge lines. And so essentially what those dissolved pavement sections are useful for is saying, okay, we have these 20-year plan records. So maybe in 3 years, we expect to do like a bridge deck overlay on this bridge. And then like 10 years after that, we expect to do another bit of work. And so we can create multiple features for those, time enable them, so that we are able to show those using in ArcGIS Online using the time slider, so that we can say, okay, for this year or this range of years, show me all the projects that might be planned to go out for that. So so there's a couple different use cases for them, but that is kind of those. So so taking a look at the bridge lines. So the data structure. So we have our from date and our to date. Anything that has a null for the to date is considered to be active. So if it has a to date, then that's considered to be a retired version of that record. We've got our route IDs, like we said, the from and to measures, the MBI that's associated with it, this minimum vertical clearance associated with those. We have those fields, but they're not really populated as far as I'm aware, because they they thought better about it, but I don't think they want to go back and change the schema because it would potentially break other stuff. But then most of the rest of it is just clerical bookkeeping stuff in terms of created, day created, edited by, and stuff like that. And then whereas the dissolved bridge lines, which are not sitting on the LRS, but have information about the LRS, have some more information, some of that's information coming from bias that I talked about before. So, and then the other nice thing about it is that we can associate specific districts with them. So there's 6 districts, as I was telling John earlier, for INDOT, and basically who's responsible for what. Just looking at the NBI doesn't necessarily give you a good clue as to who's responsible for a given bridge, but having this field in there helps to simplify filtering and symbology and stuff like that. So this being the end product after starting with basically this, starting with this, and then also the bridge points are also very similar to that, to the other one. So, Bo, did that? Yes, sir.
I did miss a question that Bo put in the chat about using the details of the anchored snapper.
Okay, yeah. So I used the anchor snapper in a couple places. So let's go to one of them. So, for example, here. Okay, so in this case, for the route ID that I wanted to make use of for it, essentially, I know that the route ID that's coming out of this one, that's the route ID. So sorry, let me take a step back. This one, I went through and I renamed it from DOT increasing equivalent route ID to just route ID, just to make it simpler here, because if they do not match up, then it presents issues. So I had to basically make those sync up so that it wouldn't give me any issues. But basically, I've got my primary routes. These are the ones that, so going back to tester, so let me double check where that fell. Is it up here? Yeah, so these were the ones where basically I said, okay, is it a 1, 2, or 9 at the beginning? So that's interstate US and state route. And then is it not on the decreasing side, and it's not an R? I'm trying to remember what R is off the top of my head. I think that's roundabout. And basically, does the end of it, so basically there's that string of numbers in the middle, which is like the route ID, not the route ID, the route number. So in that case, if it ends with like a handful of things, then make use of it. Otherwise, don't make use of them. And then basically it should be a ramp. So those were the things that it's checking against. And this is what I use to join back to a bunch of stuff to say these are the primary routes that we want to end up with. So let's go down here. So anyways, going back to the anchored snapper, essentially I get those primary routes that came out of the tester, and then I say, okay, I know the route IDs that I want for the DOT increasing equivalent, and then I want to basically group those by that route ID, and then instead of needing to do each route ID separately, Anchor Snapper will just snap it to the route ID that I specify. So in this case, I gave it a snapping distance of 5,000. I think I probably could have tightened that up a bit, but in most cases, it has no trouble finding, and it tends to run pretty quickly. So
And Adam, why did you choose that distance of 5,000? And do you want to talk a bit about what those units are for people unfamiliar with the distance?
Yeah, so here, let me show you one outlier case. Let's see here. So do you see these bridges up here? It turns out that we have bridges that are considered INDOTs, but they are nowhere near an INDOT route. And so so we wanted to not leave that value as null. So we wanted to snap to something, but in this case, this is the state fairgrounds. These are tunnels that they use for getting in and out of the dirt track in the middle for like horse races and stuff like that. So those are considered INDOT's responsibility, but the route is not something that we would typically snap to, and it's not something that that we would do. So in this case, I wanted to get something to snap it to, even though in most cases it would be well known when we're programming those that like it wouldn't necessarily be the DOT increasing equivalent, but I wanted something that was not null for those. So in these cases, it's probably snapping to somewhere over here, just to get you in roughly the general area. So that's why I bumped out that search radius fairly extensively. That answer that?
Yeah, it did. Thanks.
Okay. So other questions, thoughts?
I don't see any other. Oh, go ahead, Bo.
Hi, Adam. I think this is excellent, well-engineered process. I really appreciate that. And getting to this nitty-gritty, I know for folks like you know, dealing with one particular issue with all the complexities involving LRS and the data quality issues and data inconsistent issues, and FME provide really flexible approach to deal with it. I particularly like the, your way as I was looking through your bridge line design that you only keep, essentially only keep the MBI. You're deriving everything else coming from through the data warehouse process and grabbing the MBI assets rather than replicating them.
Mm-hmm.
And only to have redundancy of work and conflicting of values down the road. So I think that was really nice design. And I actually have quite a few questions, but I just don't want to steal the thunder. Anyone have other questions? And go ahead, because my question probably won't end. Will go last even longer. Yeah. So maybe I can ask the first question is. The MBI stores the MBI itself has the lat long identifying the beginning of the bridge, and so in your case, you don't have anything equivalent to that. I was wondering maybe your bridge point or bridge line was not originally derived from MBI's beginning point, which is pretty coarse, if you will, because it's measured using lat long. How do you reconcile the two? Because if you think, hey, MBI should be the authoritative source of bridge, and should the lat long being also being the gospel to be used, or how you kind of making sure the two data sets representing the location. One is the information, the other is geometry, geometric representation, how they jive, how you keep them, in sync.
Yeah, so the if I understood correctly, so you're basically asking if we're in terms of authoritative data sources, the Latin long is being captured as part of the bridge inventory, but not necessarily being kept in sync with the roads and highways version of the data. Is that a fair summation?
Right.
Yeah. So so essentially the Latin long, the way we have it structured in terms of like who's responsible for which portion is we have a group of bridge inspectors spread throughout the state, and they're responsible for keeping the information correct about the different bridges. The fortunate thing is that the bridges themselves, since we're never reusing them, and they, like, when the information gets updated, that's one of those attributes that it gets captured sort of at the beginning, but it's not really subject to change. However, in terms of its geometry, the Latin long that they store from the bridge inspector's point of view is not really, like, it is a kind of nice to have, but in terms of, like, when we're considering the bridge inventory, it's not really considered authoritative from that. Whereas the bridge geometry, that there's a separate fellow named Bill that he is responsible for basically making sure that the bridge inventory in roads and highways is accurate. So if we notice any discrepancies, he's the one that's responsible for cleaning all those up. And so, yeah, there's something like that where in bias, like, we capture that information because it's part of that, but it's not necessarily, it doesn't necessarily align in all cases with the data that we're capturing in roads and highways, just because in roads and highways, we don't look at the lat and the long that they're capturing from the inspection necessarily. Does that make sense?
Yeah. I was a bit surprised that you use Vanguard snapper in any capacity. Now I kind of understand why you need to do it. However, from design pattern perspective, those bridges not on the state routes, it almost has to be its separate category, maintained or managed using different process rather than just having that associate with any of the state bridges, because they are not on any of the routes. They are not on the state routes.
Mm-hmm.
So in Arizona, we do have quite a few local bridges and, on local routes, and I think through certain intergovernmental agreements still having to being maintained by the state as well. So, but in our case, we build, essentially we have the entire state routes built as part of Arno. So we associate those with kind of local routes under the Arno, kind of local Arno routes. So we don't have to, essentially, if the bridge location is a derivative of through geocoding, so there's no snapping issue. It should be on that route and just be on that route. So, but I'm sure that you have your business process and doing the way you are doing. Yeah.
Yeah. So, sorry, just so I just didn't want to skip over something. That was more of a statement as opposed to a question, right?
I would think so. It's just the way.
Yeah, I didn't want to just ignore like a question, but from what I heard, it sounded more like just as like, okay, yes, this is a comparison of the two states, right?
Right.
Okay. One thing that I did want to say was we haven't done it yet, but one of the things that we're planning on doing, sort of as one of the next big major steps, is taking FME and associating our pavement keys with the MBIs, and so the process where with the dissolved bridge sections, the dissolved bridge lines is going to be very useful for that, because when we look at a bridge, we want to know, okay, is it actually sitting on the PK? Is it on a ramp adjacent to the PK? Is it so, like, for example, this one up here, this PK stops right here, but we want to associate it with these bridges down here just because they're roughly adjacent to the PK. And the whole reason for that is because we're looking at bundling work in the future. So if we were to do a resurface on this section of road right here, would it make sense to extend the work zone down here and go ahead and get work done on these bridges? So with an eye towards like bundling our work together, that's kind of the next big major task that we're hoping to tackle with FME. So, all right.
Thanks.
For 159, that's all I had. Were there any other questions?
There's no other questions in the chat at this time, Bo. So if you have some more questions, and Adam can hang out, then that's all you.
Sure. Yeah. So another question is I would assume the centerline bridge is just computed from the line bridge you maintain mostly from the line. Then you dynamically generate the bridge centerline point.
Sorry, can you say that one more time?
Yeah, I would assume that since you maintain both the bridge center point and also the bridge line, and I'll assume the bridge center point feature class is essentially computed from the bridge line feature class.
I think there is an automated process that they do use to keep those in sync. But I would need to double check with Kevin just to make sure that that's the case, as opposed to them manually putting it. But yeah, as far as I'm aware, there is like a process that they use to keep those in sync in case something moves. So
okay,
it was kind of interesting to see here in Arizona. Some of the processes we've developed take just the center point, or the bridge beginning point, and then we use that and the bridge length to calculate the geometry length of the bridge, as well as creating center point endpoints for the bridge as well, all from the single start point of it.
Yeah, and we could, I suppose, have gone that route also, but yeah, in this case, because we already had the from and to measures for a lot of that, I just decided to go down that rabbit hole instead. So
we also tried, I think John and I tried to identify the overpass or underpass point, typically overpass point, automatically. So we know that because MBI is coding the way it is coded, MBI has many limitations in terms of character length. And our bridge, our route, feature route ID is not being used by MBI. So it's difficult to cross-relate. So we decided to try experiment using the spatial relationships, and in addition to some attributes coming from MBI, to determine if there's a bridge fly over I-10, for example, at which point. And this is where we need to assign the vertical, identify the vertical clearance for the highway law project, because the highway law needs to say, hey, at this particular milepost or mile point, we have a bridge flying over with this clearance, right? So somehow, which is underpass, right? Underpass we don't need to worry about because there's no restrictions for truck routing or what have you. So yeah, we kind of struggled, kind of having certain levels of success, but not fully completely. But anyhow, yeah. So just a comment. Yeah. Go ahead, John.
Awesome. Yeah. So I'm going to go ahead and wrap up here. And anyone who wants to hang out and talk after this, you're more than welcome to stay. So first and foremost, I just want to give a huge thank you to Adam for sharing his knowledge and experience with us in the group. Some of the work he's done is really awesome, and we've been along the same lines, replicating that over here, kind of trying to do the same thing. And then next, I want to talk about the presentation coming up on August 18th. So next month, it's going to be a little bit of a different format than we have with this. we're actually going to have a live question and answer session called Ask Me Anything. And this session is going to have 4 FME experts on the panel to answer any questions and troubleshoot workflows live and on the spot. Everyone's welcome to participate in this hands-on learning experience session, and participants will have the ability to ask questions on transformer use cases, FME best practices, as well as how to solve specific problems they're dealing with. And our panel will be composed of Dave Campanis from Safe Software, David Runnels from GeoDecisions, Mark McCart from Esri, and Bo Guo from Gistic, who is on this call currently. And aside from that, as always, if anyone is interested in presenting or knows someone who might be, feel free to have them reach out to me at john.allen@gisticinc.com. You can also reach out to me for any questions, comments, concerns you may have, or any suggestions for the group. And aside from that, thanks everyone for hanging out. And again, thanks Adam for presenting.
Thanks, y'all. This was great.